Now, in this last video of this module, we are going to discuss the future trends in vehicle diagnostic communications. We went through the various types of popular diagnostics and also efficacies of some most prevalent diagnostic communication protocols. Now, we will briefly touch upon the various future trends. Where is this diagnostic communication heading towards? Ethernet DoIP adoption is rapidly increasing for high-speed diagnostics and software over the air, which is acronymed as SOTA updates. And secure diagnostics and protocols now integrate encryption, authentication, and secure boot via UDS extensions. Now, as zonal architecture is becoming more and more prevalent in the vehicles, and there is a drastic change in the diagnostic protocol layering. What is meant by zonal architecture? Centralized UCUs using the Ethernet backbone and CAN lane at the edges will affect the diagnostic protocol layering. Now, below is the detailed explanation of most latest protocols used in vehicle diagnostics and onboard diagnostics. And first is OBD-II SAE J1979. This is already well established, and under the heading of OBD-II, these are all the various types of protocols. ISO 1615765 CAN based OBD. Next is ISO 91412, which is a older protocol. ISO 142304, which is offering a slightly faster diagnostic. SAE J1850 pulse width modulation. SAE J1850 variable pulse width modulation used in Chrysler and GM vehicles. And when it comes to, these are the already well established protocols in the market under the heading of OBD-II. Now, OBD-III is proposed, and this concept and evolution of OBD-II incorporating wireless telematics for real-time emissions monitoring and remote diagnostics. This features uses 5G, LTE and Wi-Fi to transmit diagnostic data to regulatory bodies or service centers. Okay, so this uses 5G, LTE and Wi-Fi to transmit the diagnosis. So this is more like a wireless transfer. Now coming to the diagnostic protocols beyond OBD. Modern vehicles use advanced diagnostic protocols for deeper communications, firmware updates, and high-speed data exchange. These include Unified Diagnostic Services (UDS) ISO 14229, and the purpose is used for advanced diagnostics, ECU programming, extended diagnostics beyond OBD-II. And what are the various transport layers? The first transport layer is ISO 157652. It is a CAN based UDS and this is the most common. And ISO 14230 KWP over K line legacy, and ISO 13400 DoIP diagnostics over Internet protocol, Ethernet based, and it is used in newer vehicles. And comes to features, it supports ECU programming, flash programming, and secure access for protected functions. And most important feature is it has the capability to read write data by identifier, which is labeled as 2EH or 22H for parameter adjustments. Okay, so this read and write data by identifier is used for parameter adjustments also. Now coming to the CAN, control area network, which is standardized by ISO 11898, the backbone of the modern vehicle communication, not just the diagnostics. Okay, CAN is a very robust communication protocol. It is used for almost various communications used in the vehicle. Now coming to the variants, CAN 2.0A 11-bit ID, this is basic CAN. CAN 2.0B 29-bit ID, extended CAN used in J1939 for heavy duty vehicles, and CAN FD, which is the most modern version of the CAN flexible data rate, faster up to 5 Mbps, used in newer vehicles for high speed diagnostics and updates. Now I briefly touched upon this LIN, local internet network. Purpose is low cost, low speed, but diagnostic use is limited but used for basic actuator and sensor diagnostics. Next is FlexRay, which is a very high speed one, and also it is used for diagnostics diagnostic use. And automotive Ethernet, high speed diagnostics, it can go up to 1 Gbps, especially where more and more vehicles are using ADAS and infotainment and high ECU flashing, infotainment or HMI, human machine interface, or the cluster where a lot of mapping, Google Maps are to be displayed, lot of data is coming. So under those circumstances, automotive Ethernet is used, and usage is increasingly adopted in Tesla, BMW, and other high-end vehicles. Advantages is faster firmware update, OTA over the air, and supports IP-based diagnostics. And next is SAE J1939. This is especially used for heavy-duty vehicles, and this is standard for heavy trucks, buses, agricultural construction vehicles. Protocol based on CAN and diagnostic use. Heavy-duty OBD for compliance, emissions compliance. Okay, now coming to the most, this is a very rapidly entering protocol. The purpose is high-speed multimedia diagnostics for infotainment and camera. Usage limited to diagnostics of entertainment system. So gone are the days where diagnostics were limited only for the engine. Now diagnostics were required even for the entertainment systems like camera and infotainment. Now, coming to the wireless diagnostic protocols, with the rise of connected cars, wireless diagnostics are becoming common. And wireless diagnostics like Bluetooth, Wi-Fi, where OBD-II dongles are used, they are used by aftermarket scan tools. Example, ELM327 based adapters. Limitation slower than wired diagnostics but convenient for basic scans. 4G, 5G telematics, usage for OEMs, use cellular networks for remote diagnostics, over-the-air updates, and RFID, which is key-based diagnostics. Some manufacturers use NFC for quick service authentication. As I said, this is meant for security. This RFID and NFC is majorly meant for security and proper authentication. Coming to security protocols in diagnostics, modern vehicles implement security to prevent unauthorized access. Secure onboard communication authenticates diagnostic messages, and TLS SSL, which is a part of the diagnostic over internet protocol, they use encrypted Ethernet diagnostics. Encrypted means the message which goes from scanner to the ECU cannot be hacked by any external person. And and hardware security modules used in UDS for security flashing. Vehicle diagnostics have evolved from simple OBD protocols to high-speed, secure, and wireless communication methods. The latest trends include CAN FD and Automotive Ethernet for faster diagnostics, UDS and DoIP for advanced ECU programming, 5G and OTA updates for remote diagnostics, and enhanced security for prevent hacking. Okay, so from OBD, which limits itself to only engine health of the engine, now OBD has spread its tentacles, or it has spread into various parts like ADAS, infotainment, cockpit, and also body modules. And for all those diagnostics, various protocols like CAN FD, UDS, 5G, and OTA enhanced security have come into the picture. Okay, so each protocol serves a specific purpose, from basic OBD checks to full ECU reprogramming, ensuring modern vehicles are both diagnosable and secure. All right, so hope all of you got a brief idea about the future and the future trends of the diagnostics. Thank you.